Hello, maurieo. In this instructional video, I'm going to take a look at a little problem that a student sent in to me. It highlights a few little issues and I'm also using it to try and highlight the benefit of asking questions. And by having a go yourself and then going from there, because I think that gives ultimately a better understanding of the topic, and in my view there. So what's the situation here? Well, as an introductory exercise, and excuse me for my spider scrawl here, but hopefully it'll show what we're trying to do. So initially these students set up an instrument here and set 0 to this post significant distance away, a couple of 100 meters away, with a prism on it. We then observed to an adjacent post just some 8 meters away, and then also to the corner of a container there. And what I asked them to do is just to calculate these bearings and distances between the 3 marks. We measured these left and right face, so there's a field note for these and the distances, just hanging lines, and we're just going to calculate between them. Now, and I said to just assume coordinates of 700,000 and 300,000 there, and put them in. And now what the student has done here is, as you can see, these lines are radiations, so each one gets run out in the Travis sheet and is added to the 7,000. The student here has added them cumulatively rather than individually going back to that one. So that plus that coordinate's correct. This one here should be 7,000 plus that, and this one here 7,000 minus that, and the same there on the easting side. So that's a bit problematical. Then we've got some little issues down here with what to do. So that's the situation, and I'll put it in. So that's post 1 and corner. So I've been working with an Excel Travis sheet. So these students, I might add, these students have not been introduced to software yet. We're just doing this, getting an understanding of it. So we've got a situation where we just take the cosine of the bearing and multiply it by the distance to get the northing, and the sine of the easting and multiply it by the distance to get that there. So I have on some other exercises worked through with an Excel spreadsheet. So these ones here, these are the radiations. So as you can see here, I've put in the same coordinate bearings and distances, hopefully. I'm in trouble if I haven't, but anyway, I've put them in there and I've run them out, and as you can see here, I have that plus that goes there, that plus 2.794 goes there, and that minus that in here, and same for the the eastings. So this is northing and easting as it is on the sheet. I haven't quite filled it out all here. Now what we then want to do is we want to calculate from the post to post 1. So all of the information that I have calculated I have shown in red. So these have all been shown in red, and well, technically these here are calculated as well, so they should be in red as well, as should these, because this is all calculated material. Okay, these here, I'll probably these are a check. So I'm going to put those in, I'll put those in the green just to, oh, that's not very, that's better. That's a better green to read. That's my checks. I'll just put all those in a nice green to do it there. And so let's explain what's going on there. All right, so having determined the coordinates for these points, we want to go from post. So we just, you'll see that coordinate is in there, and that one's in there, and then post 1 is same coordinate and same coordinate in there. So we put those in there, and then, well, what I do is I go minus that plus that, and that gives me the right coordinate, or the right ordinate for that, as I call it, and that one there. So if we apply that to the 3,000, we get that, and we subtract that from that, we get that. And that gives us these two values here. Now, this is where I need to determine, well, determining the distance is quite easy. That's just Pythagoras. That squared plus that squared. Take the square root of that, will give you the distance. And then we just got to determine this angle in here. So I've drawn the little triangle. Negative is down, so negative north, negative east, which is west. So like so. And this is our resultant here. So we can work out this little angle here. It's tan to the negative 1. Opposite, don't worry about the signs, we just keep them all positive, and over the 120.58. Now I've done this on my calculator. I can do it in Excel, but it's quite tricky because we have to convert from radians to degrees and then to degrees, minutes and seconds. So for this purposes of this exercise, I have done it on my calculator there. So I just tan to the negative 1, 7.58 over 120.158 gives us an angle of 3 degrees 36, which we can see this is 180 here, so 183, 36, 34. I've calculated that by Pythagoras, and so that's all my calculated, and that's there. Now, just by way of a check, I've just put the 183, 36, 30 in there and the 120, so just copied them into there and then just gone cosine of that times that and sine of that times that, and we're in agreement. So that is the inverse or the reverse or the missing line of that. So then it's on to the next one, and again we just get the coordinates from up the top, post 1 coordinates to here and corner coordinates to here. Work out the ordinates, draw the little triangle, work out what angle it is. So in this case here, we've got the angle in there of 78 degrees 30.09, but that's in there. So that's going to be, here's 180 down here. So we can take that away from 180 to give us the bearing. Okay, the bearing there, and a 101, 29, 51. And we run that out and we see we get exactly the same signs and everything. So that's my little check for that. That's all done and dusted. And then for the remaining one, which is the corner back to the post, same thing again. There's the corner. So from the corner to the post, work out these here. That comes out easily. And then we can see this little angle in here, tan to the negative 1, 6.210 over 122.963, gives us 2 degrees 53.28. Subtract that from 360 to get the bearing, and there we go, and we check it out, and it's all good. So, yeah, really appreciate the students sending that in, and so I could have a good look at it, and hopefully we'll get some more questions from there, or a good understanding of exactly what's going on. And it's sorted the problem out, hopefully in a memorable way. Obviously there was a little bit of confusion. We've sorted the confusion, and from that hopefully some learning. So yeah, All good. Cheers. See you.